Welcome to Unit 10, Conic Sections. This is going to be an exciting journey for all of us for multiple reasons. I feel it fair to tell you up front that this unit may or may not be the most difficult unit of our year. For example, this is my third or fourth time recording this video, deciding how to present this information to you. So, let that determine, if you will, how you will feel about this unit. But here's what I do want you to know, that even though this unit is a bit more involved than other units, I'm doing my best for you, which is why I am making this third or fourth video. Okay, before we get super into it, let us take note of the joke of the day. What type of music are balloons most afraid of? Pop music. Oh, what a good one. Okay, moving on. So let's talk about what the heck is a conic section. Okay, conic meaning cone. If you look at this picture at the bottom, you have two inverted cones, and that means that it's two cones that are facing tip to tip. And what's going to happen is we're going to take a plane and we're just going to cut it through these inverted cones, and depending on how we place this plane, that will determine what kind of shape we would get. Like if we were to pull the cones apart, what is the shape of that cross section, meaning that flat surface that's like you cut it through and it's like after you cut it, oh, what shape is the solid surface? Anyway, so we have parabolas, circles, ellipses, hyperbolas. Ellipses and hyperbolas you probably haven't even heard of yet, but parabolas and circles, hey, we've talked about those this year. So we're just going to start with parabolas because that is our most familiar territory. What you need to realize is that with parabolas, we're going to be spicing it up right from the get-go because parabolas are going to have a bit of a different definition than we've been used to. We've been used to parabola is the graph shape of a quadratic. You know, we have y equals x squared as our parent function there. So instead of thinking about this in a function sense, here's what we're going to think about it. A parabola, fun fact, the set of all points that are equidistant from a given point and that point is called the focus, and a given line, and that line is called the directrix. Isn't that a fun word? Okay, here's what this means. I would like to point your attention to our lovely picture at the left here. So here you have the focus in red. You have the directrix also in red. And literally what you can do is you can pick any point on this parabola, like this point here. And if you're to calculate the distance from that point to the directrix or that point to the focus, you're going to get the same distance. That happens with any point on here. For heaven's sakes, don't mind me and my technology skills. Okay, so that's what's going on there. So what's going to happen is this can look like in a few different formats. The one that we're most used to is, just a normal upward facing parabola. So that'd be something like, okay, this point, I'm going to call this the focus, so I'm going to call that point F. And now I'm going to have the directrix, just going to be this nice line here. And so the vertex has to be halfway between those. So the vertex would be about here. And then you'd get your parabola that gets to form. So focus, directrix, here's your vertex. All right, well, here's what we know. The vertex is the coordinate HK. Throwback to vertex form. And turns out, we'll just come back to that second thought later. You could also have a vertical line. And you could have a point over here. And say, okay, there's my focus. And you're going, oh, so this means that I can actually have a horizontal parabola. Because guess what? There's the vertex. And so it looks something like this. Ah, snap. That vertex is still the coordinate HK, which is nice. But yeah, because we're not thinking of parabolas as necessarily functions at this time, we can have a vertical parabola or we can have a horizontal parabola. So what I'm going to show you next would be the equations for both of these. Okay, before we get into equations, here's what I need you to know. This distance from the vertex to the focus, we're going to call that P. It happens on both, doesn't matter which way your parabola is opening. Turns out, well, hey, if the parabola is the set of all points that are equidistant from the focus and the directrix, that means that the vertex has to be placed halfway between, which means that distance between vertex and directrix is also P. Okay? So let's just write down what we know. P. Distance from the vertex to either the focus or the directrix. Okay. Here's what we got equation-wise. We're going to write this equation in what we call transformational form. Let's write that down somewhere. Transformational form. All right, here's what we got. For a vertical parabola, here's what you got. 4p times y minus k equals x minus h squared. You might be probably thinking, where in the heck did that come from? All right, well, we know what P is. P is that distance from the vertex to the focus or directrix. There's a pretty nifty proof out there as to why is it 4p. It's very computational. I'll probably post a different video about it because I think it's pretty cool, and so did my students last year. But hey, this x minus h and that y minus k, don't we know what hk is? Hk is the vertex. Turns out this transformational form is just a different way to arrange vertex form of a parabola. If you remember, vertex form was that y equals a times x minus h squared plus k. So if I was to subtract the k, that's where that y minus k, and then turns out with the a value, which we normally base, the 1a, 3a, 5a off of, turns out that a value is equal to the reciprocal of 4p, which that means that 4p is this reciprocal of the a value. So if you were to see it in vertex form as such, you take the reciprocal to get 4p. So that's where that's all coming from. This is kind of really important, hence me writing it in red. I can also show you where that comes from, but I think for now it's best to just keep it as simple as we can. So here's that's transformational form with a vertical parabola. With this horizontal parabola over here, check this out. 4p times x minus h equals y minus k squared. Do you see the difference? All that's happened is that this x minus h has switched sides, or the y minus k has switched sides. And more importantly than the switching sides is which term is being squared, or which variable is being squared, I should say. Because if you have a vertical parabola, that's because you have x squared, which is what we've dealt with. But if you have a horizontal parabola, that is because y is being squared. So we have the 4p times y minus k equals x minus h squared. Also, something important to know in this form. Oh, look, it's in red. You think that's important? The squared term is by itself. Vertex form, we knew that y was by itself, but transformational form, it's just the entirety of the squared term, which is why I have the y minus k squared and the x minus h squared. Okay, so that's general idea of what's going on. I think it's going to be a little bit more clear as to like why am I using these things as we do some examples. So we're going to go ahead to the next page. You know, we're going to come back to this idea in a second, and let's just do an example. All right, all we're going to do is identify the vertex, the focus, and the directrix. All right, so let's take a look. Negative 1/2 x plus 7 equals y minus 6 squared. All right. There's some important things to know. Once again, remember we talked about our vertex. This is a coordinate hk. And if you take a look, we're going to zoom back. Notice that I have opposite k and opposite h this time. We're used to opposite h, but I don't think we've seen opposite k before. So we're just going to go ahead and take note of that. That means that as I'm pulling out the vertex, I need to take the opposite of both of those in the parentheses, and mind you, x comes first, as with coordinates. So my vertex is going to be negative 7, positive 6. All right. In order to find the focus and the directrix, well, that's going to involve knowing which way is my parabola opening. And to help guide you with that, I'm going to draw you a nifty little chart, and I'm going to choose it to do it in pink because that is a happy color. Okay, here's what we talked about. Dun, dun, dun. And good enough. All right, we know we have x squared, and we could have y squared. Well, I know x squared can open up or it can open down. What was it that determined that x squared opened down? It was if you had a negative as part of that leading coefficient, it opens up if it's positive. And this makes sense because, well, x squared opening up, that's towards the positive direction of your graph, or opening down, that's towards the negative direction of the graph. Well, let's think about it as y squared. It's a sideways. If it's opening up towards the positive side of the graph, that would be the right side of the graph. If it's opening up towards the negative end of the graph, that's going to be opening towards the left side. So this is going to help us because as I'm identifying all these things, I'm going to have to know which direction is it going. So here's what I notice here. I see that I have, I'll switch that color. I'm all about color coding. I see I have a negative, and I see that it's y being squared. So that tells me that this parabola is going to open up to the left. And so in order to find the focus, here, let's write down that equation, just our transformational form equation, just one more time. We had 4p x minus h equals y minus k squared. What was p? The distance between the focus and the vertex, or the vertex and the directrix. So here's what I know. I know that 4p is equal to negative 1/2. Well, that makes it nice because I know that p, I'm just going to divide both sides by 4, and I get negative 1/8. So if I know that it's opening this way, the focus is always going to be inside of the parabola, and the directrix is always outside. So with this, notice that I'm moving, like here's my vertex, and that means I gotta move left and I've gotta move right to find the coordinates of the focus for the line for the directrix. So with this happening, I know that my x values are changing because it's going from side to side. My y value is not changing. So this 6 does not change because this is not moving up or down. It's only moving side to side. Well, that means to find the focus, that means I need to move to the left, which is a negative direction. So I need to do negative 7 minus 1/8. I'm going to do a common denominator for that. So we get negative 56 over 8 minus 1/8. And I should get negative 57 over 8. So my focus is negative 57 over 8, 6. For the directrix, I know that I need to move the 1/8 to the right, which means I'm going to do negative 7 plus 1/8. So once again, common denominator. I get negative 55 over 8. So for my directrix, I see that this is a vertical line. Vertical lines are always given as x equals. So this is going to be at x equals negative 55 over 8. So there we go. There was the vertex, there's the focus, and there's the directrix. Okay. So we're starting to see this is different. That's okay. It's okay to be different. Let's look at another example. Maybe let's do some easier numbers this time. Let's go 8 times y plus 9 equals x plus 4 squared. Okay, once again, we need to find the vertex, focus, and the directrix. I'm going to copy down this table one more time, just because I think it's helpful to reference. So it was x squared, y squared, positive, negative, down, right, left. All right. Let's start with the vertex. Vertex, that's familiar territory. All right, remember, we're taking opposites. We always start with x. So we got -4, -9. Okay, let's figure out which way this is opening. I see x is being squared, so it has to be up or down. I see it's all positive, which means that this parabola is opening up. Once again, if I'm to write down that transformational form, minus k equals x minus h squared, I know that p is the distance from the vertex to the focus. Well, 4p, I know, equals 8. Divide both sides, and that tells me that p equals 2. So here's what I know. If my parabola is opening up, my vertex is here, my focus has to be inside my parabola, and my directrix has to be outside. Well, if you notice, if I'm just moving up and down to get to those points, then my x value doesn't change. So this -4 stays the same. So I know to get to my focus, my y value, which is -9, well, we're going to go up 2 because we got to move up that distance of p. So I got to go +2, which gets me to -7. So my focus is at -4, -7. If I want the directrix, if this is a horizontal line, that's always given by y equals, so I know my directrix. I'm going to take that vertex and now I'm going to go down further with that p value, so this time we're going to subtract because I am going down. So I get -11, so my directrix is y equals -11. Okay, something that I need you to know, if we're talking about like axis of symmetry, we always knew that with horizontal parabolas, with vertical parabolas, the axis of symmetry, it's that line through the vertex. And I always knew it was x equals h, meaning the x coordinate of the vertex. Well, what happens over here? Axis of symmetry is sideways now. So it turns out my axis of symmetry is always y equals k. I'm going to add that over to our main page. Axis of symmetry, x equals h. Axis of symmetry, y equals k. It's just saying, where is it folding over, basically. All right, before we get into graphing, here's something I want to point out. Back to this fun page. I have just screenshotted a few different examples of, your basics, right? Here's what I'm wanting you to notice. 4p, 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 okay? What's the deal here? 4p is a thing. You can look it up in any textbook. You can find it in any online example. 4p is a thing. Now, let us look at what MathBase says. Solve for a, the focal length. X squared equals -4a. 4a. Are you freaking kidding me? When we've talked about how the letter is P, this should be P, friends. X squared equals -4py. Okay, so when it talks about the focal length, here's what I need you to know. The focal length, this is going to be the same thing as the distance from the vertex to the focus or the directrix, because those distances are the same. That's what it's talking about with focal length. And for some reason in your hint, it decided to name it A, which is a terrible decision because, like I pointed out to you in the beginning, oh look, A, that's in vertex form. We're in transformational form. So that irritated me. I cannot fix it. There's still some good things, good math it wants you to do, but I just need you to know when it says solve for A, you're really solving for P. So do not get confused. So for example, if it gives you x squared equals negative 12y, and it says solve for A, it really means P. 4P is negative 12. That means P is negative 3. Don't let it fool you. This negative 3 is what I would type in here. But it makes you say A equals negative 3. But we know better. We know better. Okay. Last thing I want to cover in this video is just going to be graphing. And we're just gonna actually shove. Nope, we're gonna make it 1/2. All right, graphing from transformational form. A lot of this, let's remind ourselves actually, how did we even graph parabolas? We only needed two things to graph a parabola. We needed the vertex. We also need the A value. Because if you remember, we go 1A, 3A, 5A. Well, here's the problem. This is transformational form, so this value is 4P. Well, vertex form was y equals a times x minus h squared plus k. By manipulating that form, just like I told you a little bit earlier, we knew that 4p equals 1 over a, or that a equals 1 over 4p. And another way we could say it, instead of 1 over, is we could say it's the reciprocal. So in transformational form, as we are in such with this example, we can pick out the vertex pretty confidently. Remember, x comes first. So start with opposite. So I got positive 5, positive 4. And if I want to follow this 1A, 3A, 5A pattern, all I have to do is take the reciprocal of this 4P here, because that gives me the A value. So if I know that 4P is equal to 1/2, well, the reciprocal of that gives me the A value, which is 2. And with that, I can do the 1A, 3A, 5A. 1 times A is 2. 3 times A is 6. 5 times A is 10. And now I have all the tools that I need to graph. So it looks like we're going to have to need a big old graph. Oh, it also might be helpful to know which way it's opening. Well, I see it's all positive. It's an x squared. Positive x squared opens up and down. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. From there, I'm just going to follow my A value over 1 up 2. For 1, 1, 2, 3, 4, 5, 6. For 1 up 2. For 1, 1, 2, 3, 4, 5, 6. Okay, there's the parabola, but we have been learning about a focus and a directrix, so we better plot those as well. Well, P, 4P is equal to 1/2. Remember, P is the distance to those things, so I divide both sides by 4, and I get 1/8. Well, that means my focus is going to be 1/8 of the way, which is going to be teeny, teeny, teeny. And my directrix is also going to be 1/8 of the way, which is teeny, teeny, teeny. And I could find those locations if I wanted to. We better do it just because it doesn't hurt to have another example. Looks like to get to the focus, I have to add. Notice that because, let's just pick up the axis of symmetry. Axis of symmetry here goes horizontal, gosh, it goes vertically, which makes it an x equals, and it's 5. So that 5 stays the same, and this 5 will not change as I find my focus. So I can take the y value of the vertex and then add that distance, because I'm going up to get that distance. We're going to do a common denominator. 1/8 equals 33/8. So that means my focus is going to be at 5 and then 33/8. My directrix, well, I'm going down, so I subtract the 1/8, common denominator, and I get a 31/8. So y equals, because y equals is a horizontal line, I get 31/8. Okay, I want to do one more example. I might have said that before, but I want to give you a horizontal parabola to practice with real quick. Graph negative x minus 3 equals y minus 2 squared. All right. Let's see what we got. Step 1, find the vertex. Remember, x comes first, taking opposites. 3, positive 2. I know that this negative, it's like a -1, is 4p. The reciprocal of that gives me a. Well, the reciprocal of -1 is still -1. So that means I can do my 1a, 3a, 5a. 1 times -1 is -1, -3, -5. And it's nice to know, and also necessary to know, which way is this opening. Well, here's what I see. I have a negative, and I have y squared. That means we open up to the left. Let's make ourselves a graph. Okay, +3, +2, there's my vertex. And so negative direction just means we're moving to the left. So this time, I'm going to go up 1 over 1, up 1 over 3. Same in both directions. There we go. Let's find the focus. Well, if I know that 4p equals -1, then p is a -1/4. the focus has to be inside the parabola, so I know that I'm going to move 1/4 from my vertex, and I'm going to move 1/4 in the other direction to get my directrix. Because I am moving left and right, the x value changes. Notice I did not move up or down to get to the focus, which means that this y coordinate is going to stay the same for everything. So if I'm moving to the left, that's moving in the negative direction, so that means subtraction. So 3 minus 1/4, common denominator, 11/4. So my focus is 11/4, positive 2. My directrix, well, I move to the right, which is a positive direction, so I can add 1/4. Okay, that's 13/4. If I was to write that equation, well, this is a vertical line. Vertical lines are always x equals, which means my directrix is going to be at x equals 13/4. And that's the first part.